Today we're going to be modeling a rain garden using GIFMod. Our conceptual model for the rain garden can be found in figure 6.1 of the GIFMod user's manual. So we have our pond, our soil layer, our storage layer which feeds into our sewage system, our native soil, and groundwater. The two main factors controlling water retention is the evapotranspiration and the vertical percolation of water into the soil layer. We're also going to include a water inflow time series, and we're going to go ahead and get started. So first we're going to create a pond, and we are going to change the bottom area of the pond to 354.54 meters squared. Alright, so we're going to add a substrate layer, and we're going to discretize it into 5 sublayers. We're doing this so we can later find the moisture content or any other value we want in the sublayers, and we can figure out the differences and compare the differences in the moisture content or flow or any value that you want to see. So we're going to go ahead and start by renaming this, and then we're going to add some properties. So the bottom area is 354.54. The bottom elevation is negative 0.14. We're going to change the soil type to, or we're going to change the subtype to a sandy loam. We're going to go ahead down to depth and change it to 0.14. Vapor diffusion coefficient to 0.001. And we're going to go ahead and connect the pond layer to the substrate layer, and we're going to change the length of the connector to 0.07. Alright, perfect. So we're going to go ahead and right click on substrate 1, and we're going to make 5 rows. As you'll see, the 5 rows get created, and now we're going to go ahead and add our aggregate storage compound, and we're going to bring it below substrate 5. We're going to have to change some of the properties of our storage. Bottom area to 354.54. The bottom elevation at negative 1.08. Depth to 0.38 meters. Saturated hydraulic conductivity is going to be changed to 80. Saturated moisture content is going to be changed to 0.45. And the vapor diffusion coefficient is going to be 0.001. We're going to go ahead and connect these layers, and the length of this connector is going to be 0.07 meters. Alright, now we're going to go ahead and add the native soil layer as found here. The native soil layer is going to be a clay loam. So we're going to go ahead and bring it all the way down, and we're going to go and change the name to soil 1. The bottom area, like the rest, is going to be 354.54. The bottom elevation is going to be negative 1.58 meters. Depth is going to be 0.5. vapor diffusion coefficient is going to be 0.001, and now we're going to go ahead and connect the storage to the soil, and the length is going to be set to 0.25 meters. Alright, now we're going to go ahead and discretize this native soil layer into 3 layers. Now we're going to go ahead and add the groundwater. So we're going to assume the water table will not be affected by recharge, and we can do this by setting the head storage relationship to be a fixed head. So to do that, we're going to go ahead and add a Darcy block and bring it down to the bottom. So we're going to name this Darcy block groundwater. Change the bottom area to 354.54, the bottom elevation to negative 3.58, a depth of 1 meter, the head storage relationship is going to be set to negative 2.58. Vapor diffusion coefficient 0.001. Saturated moisture content is 0.35, and the initial moisture content is 0.35. So we're going to go ahead and connect this layer to the soil, change the length to 0.25, and now we're going to go ahead and add receiving water. So this is going to represent our sewer system, and it's a convenient way to impose a downstream boundary, and it's also a convenient way to be able to see our outflow volume. And it's going to be set to never have backflow. So to do this, we're going to go ahead and add our pond, and we're going to name it receiving water. The bottom area is going to be set to 1000. The bottom elevation is going to be set to -5. The head storage relationship is going to be set to -3, and we're going to go ahead and change precipitation to no, so it's not affected by our inflow time series for the pond. Alright, now we need to connect the pond 1 to the receiving water. We're going to go ahead and click on the connector and change the type to a pipe. We have to change the diameter 0.1, change the length to 10 meters. Starting elevation is going to be negative 0.78, and our ending elevation is going to be negative 1.18 meters. Alright, now we're going to actually, I just put in the data for the storage to receiving water connector. So we're going to go ahead and just change the start and end elevation to the correct values, which is 0.2 for start and negative 1.18. Alright, and now for the storage to receiving water connector, we're going to change the type to a pipe, diameter to 0.1, length to 10, start elevation as negative 0.78 and the ending elevation as negative 0.01.18. Alright, we're going to click on our pond and add our inflow time series. This can be found in the GIFMod projects, examples, and RainGarden. If we right click and click data, we can see the inflow time series. Now we're going to go to evapotranspirations and right click, add evapotranspiration. For the time series, we're going to go to the same location and add the evaporation.txt. Now we're going to go ahead and click on our pond, go down to evapotranspiration, and click the newly added evapotranspiration unit. So in order to set the time for our project, we'll go into our simulation start, which will be 2012, March 1st. And our ending time is going to be 1 month later. Or at the end of the month on the 31st. Alright, we're going to go ahead and save this. And we're going to go ahead and run. Make sure everything runs without error. And we're going to go ahead and see this screen. And the simulation will probably take around 10 minutes. And I will meet you guys on the other side of the simulation. Alright, so the simulation is ended, and we can go ahead and check the results. So first we're going to check the head for pond 1, and as we can see, it has a maximum on March 23rd of around 7 centimeters. Now the overflow, in order for this overflow connector to have seen any water, the head would have had to have been greater than 20 centimeters. So if we plot the flow, we're going to go ahead and see zero flow that went through that connector. So now we're going to go ahead and check the storage 1 to receiving water connector, and as we can see, there are some fluctuations that occurred, March 23rd being the highest, from water leaving the storage and entering the receiving water, which was representing our sewer system. Alright, and now we're going to go ahead and graph all of the moisture contents of the 5 substrate layers. And we can right click and copy and paste them so they're all overlaid. Alright, so once they're all overlaid, you can compare them, do whatever you need to do with the data. For any other soil block, you can observe any other data, and the data will be saved examples in project examples, and these 3 it's going to be where the path is. So since this RainGarden folder is here in examples, the output text will be put here also, and it's just going to be the data, and for any particles there's going to be all the data. So this has been the simple RainGarden tutorial. Thank you.